Hello and welcome to today's lab. Within your VCL session, navigate to the Blackboard course webpage for Government 300. Along the left-hand menu, choose Data, and then select the States dataset. And you'll be prompted to either open or save. Click Open, and this will start a session of SPSS. Today's lab introduces multivariate regression. Multivariate regression is simply regression that considers two or more independent variables and their independent effect on the dependent variable. So recall from the lab video on regression graphics, we considered the correlation between a state's percentage of high church attenders and percentage of women in the legislature. We found a statistically significant relationship between these two variables such that an increase in percentage of high-frequency church attenders in a state corresponded to a decrease in the percentage of women in the state's legislature. So let's quickly run this regression analysis again in SPSS. Go to Analyze, Regression, choose Linear, and we'll sort our variables and choose the attend percentage, place that into the independent box, and all the way down on the bottom, the percentage of women in the legislature, state legislatures in 2010 into our dependent box, and click OK. Alright, recall that R square is 0.419, meaning that 41.9% of the variation in our dependent variable is explained when we know values of our independent variable. Notice that both p-values are significant for the F statistic and for our independent variable, and our slope tells us that for each additional percentage of high church attenders, we would expect the percentage of women legislators in that state to decrease by 0.47 percentage points. But what if we wanted to explain more variation in a state's percentage of women legislatures? With multivariate regression, to consider the independent effect of more than one independent variable on our dependent variable, we simply add other plausible independent variables to the equation. So with multivariate regression, you can estimate the partial effect of an independent variable on a dependent variable, controlling for the effects of other independent variables simultaneously. Suppose we wanted to control for the percentage of people in a given state that identify as liberal. Perhaps we theorize that holding the percentage of high church attenders constant, the more liberal states are more likely to have more women legislators. Remember that multivariate regression allows us to interpret a given beta coefficient while holding the effects of all other variables constant. So let's return to our original regression model and add this additional independent variable. So click out of your output, and we'll navigate back up to Analyze and down to Regression and choose Linear, and our relationship should still be present here. And we're going to place our new independent variable, our second independent variable, which is the percentage of people in that state identifying as liberal. Place that into the independent box in addition to our other independent variable, and we'll click OK. Alright, note that a number of things have changed. The R square has increased from 0.419 to 0.509, meaning that 50.9% of our variation is explained when we add this additional independent variable to the model. Additionally, the model is significant, indicated by the F statistic in the ANOVA summary. Moreover, both independent variables are also significant, indicated by the p-values for each one. The values for beta have also changed. By holding the percentage of high-frequency church attenders constant, we now observe a stronger and positive effect on the dependent variable with a beta value of 0.75 for our independent variable of percentage of the state that identifies as liberal. Not surprisingly, our beta value for our original independent variable has gone down because more of the variation in our dependent variable is being explained with the introduction of our additional independent variable. We can now interpret the new variable. For each 1% increase in the proportion of people identifying as liberals in a state, we expect the percentage of women in the state legislature on average to increase by 0.75 percentage points. To reiterate, with the introduction of an additional independent variable into our regression model, we can now interpret the independent effect of each of our independent variables on our dependent variable. Thus, we can assess each independent variable's partial effect on the dependent variable. In our relationship, both the percentage of high church attenders in a given state and the percentage of people identifying as liberal in a given state have a statistically significant effect on our dependent variable of percentage of women in the state legislature.
There's not much left to do, Government 300s, but study for the final. Watch for postings on Blackboard for the availability of study sessions, and also watch Blackboard for study guides. Good luck on the final.